Earlier in the year, we talked about graphing inequalities with just one variable. Today, we're going to be talking about graphing inequalities in two variables. So let me show you what that means. First of all, let's talk about some symbols and what it means as far as graphs go. So here we have the greater than symbol. And if you remember for one variable, the graph of greater than had an open circle and it pointed to the right. If we're graphing in two variables, what that's going to mean for the graph is that we're going to have a dashed line. And that probably could have been a little bit straighter. And you'll see what I mean by a dashed line in just a little bit. Next one is going to be less than. And if it was just one variable on a number line, it would be an open circle pointing to the left. And that's also going to be a dashed line. And again, you'll see what I mean in just a bit. Then we have greater than or equal to, and that was a closed circle that points to the right. If we have greater than or equal to with two variables, it's going to be a solid line. And with less than or equal to, it's going to be the same thing. So with one variable on a number line, it would be a closed circle that points to the left. With two variables, it's going to be a solid line. So this is a really important thing to remember when we're graphing. So here's our first example. We want to sketch the graph of y is greater than 2x minus 4. So the first thing we're going to do is label our axes from -5 to 5 on both. Go ahead and do this on your paper as well. And then we're going to graph this exactly how we would if this was an equal sign. So we're going to look at the slope and the y-intercept. The slope, remember, is going to be the number in front of x, which is 2 or 2 over 1. And the y-intercept is the number by itself. In this case, it's -4. So I'm going to start with the y-intercept at -4. And I'm going to follow the slope of 2 over 1, up 2 over 1, and we can keep going, up 2 over 1, and so on. Now I'm going to pay attention to the symbol. Because it's greater than, this is going to get a dashed line. So I'm going to use this green line here because it's already dashed. And to get straight lines, you can use the lid on your calculator case. But make sure you try to have straight lines. So then after I graph the line, there's going to be some shading involved. So with inequalities in two variables, we're going to be shading half of the graph. And so here's how to figure out what way to shade. We're going to check a point. I would say 0, 0, the origin, is the easiest point to check. So I'm going to start with the original inequality. And I'm going to check the point 0, 0. So I'm going to plug in 0 for y and x and see if it works. See if this inequality holds true. So I end up with 0 is greater than -4, which is true, which means 0, 0, this point right here in the origin is part of the solution. Because of that, we're going to shade on the side that includes 0, 0. So we're going to shade all of this, and this is part of graphing the inequality. If 0, 0 did not work, then we would not include it and we would shade the other way. Let's take a look at the next example. So we're going to graph the same exact line. So the slope is still 2 over 1, y-intercept is -4. Go ahead and draw another sketch because this one's going to be a little bit different than the one we just graphed. So the line of it is the same. We're going to start at -4, and we're still going to go up 2 over 1, up 2 over 1, and so on. However, this time I have a less than or equal to sign, which means now the line is going to be a solid line. And what that means is that this graph is going to include all of the ordered pairs that fall on this line. When it's a dashed line, it does not include those ordered pairs. We're going to be talking more about that in class. So make sure you have arrows on the ends of those. And now we're going to check again the point 0, 0 to see which way we're going to shade. So we're always going to start with the original inequality. I'm going to substitute 0 for x and y. And see if it holds true. So I end up with 0 is less than or equal to -4, which is not true. So that does not work out. I'll just put a line through that, which means it cannot include the point 0, 0. 0, 0 is not part of this solution. So I'm going to shade the other way so that I do not include 0, 0. So now this is the solution. This is the graph. So every single ordered pair that falls in this shaded region and on the line is part of this graph. And that's how to graph inequalities. Here's one more for you to try on your own, and we'll continue talking about this in class.